Assalamualaikum warahmatullahi wabarakatuh. Today, our group want to present to you about our PBL project. Before we go further, I want to introduce you my group members. This is my group members that you can see in my screen. Our group leader is Muhammad Fauzan Shafi bin Muhammad Faudi. Okay, let's begin. I will present to you about the introduction of differentiation. Differentiation is the process of the finding derivative of a function is called differentiation in calculus. A derivative is the rate of change of a function with respect to another quantity. The law of the differential calculus were laid by Sir Isaac Newton. The principle of the limit and derivative are used in many disciplines of science. Differentiation and integration form the major concept of the calculus. That is the technique of differentiation to find the derivative like algebraic function, trigonometric function, and exponential function. If let's say x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. This is a general expression of derivative of a function and is represented as differentiation of fx is equal to dy over dx, where y equal to fx is any function. Okay, that's all from me. I will pass it to my group members to continue the presentation. Thank you.
Other than this, we have a learning issue. Firstly, how we solve a problem using the information given, and next is how many dimensions are needed to minimize the cost of metal to the manufacturer's gain, and what is the method used to solve the problem to define the dimension will minimize the cost of the metal to manufacture gains. After that, we have resources needed is internet, technical, mathematics, 2 books, and finally is discussion. I think that's all from me. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Rasmin Azri bin Abdul Wahid. Metric number is AA21107. So for this slide, I will show you about the filler table. So firstly is about fact. Firstly is a cylindrical can is to be made to hold 1000 milliliter of oils. The dimension that will minimize the cost of the method to the furniture can in the second fact. After that, I will share you about the ideas that I have in this question. Firstly, using the equation surface area is equal to 2 pi radius power of 2 plus 2 pi radius h, and volume of cylinder V equal to the pi r power of 2 and h. Next is using differentiation method to solve substitution problem related to the minimum differentiation ds dr equal to 0. And the lastly is find the radius and height of the can.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan Shafi bin Muhammad Faudi, and this time I will present to you all about the problem solving from our group topic. The question is, a cylinder can is to be made to be hold 1000 milliliter of oil. So we have to find the dimension that will minimize the cost of the metal to manufacture the can. There are two given equations, which is the hint for to solve this question. The first one is the surface area is S is equal to 2 pi r square plus 2 pi r h. R in this question is radius of the cylinder and the h is the height of the cylinder. The second given hint is V equals to pi r to pi r square h. There are one more additional hint that we have to find, and we have to find to solve this problem, which is we don't need to do the differentiation twice, because one differentiation is enough to find the minimum cost of the metal. We have already know that we only need to find the minimum point in this question. They are already been highlighted in the last sentence of our question. So we don't need to identify whether the differentiation of the equation is in maximum or minimum point. So that's all for me. We will move to solution and the discussion for this problem background. Thank you.
My name is Mama Afi Benazmi. I will explain about the solutions. First of all, we know that the formula is S equal to 2 pi r squared plus 2 pi rh, and V equal to 1000 and h equal to 1000 divided by pi r squared. So S equal to 2 pi r squared plus 2 pi r multiply 1000 divided by pi r squared, and then we get S equal to 2 pi r squared plus 2000 r negative 1 ds per dr equal to 4 pi r minus 2000 r negative 2. The minimum is, we know, ds per dr equal to 0. So 4 pi r cube minus 2000 equal to 0. And we simplifying that, and until the last we got um, r equal to 5.419, and we can determine the h and s. So h equal to 1000 divided by divided by pi multiply 5.49 squared, and we get 10.839. And lastly is s equal to 2 pi multiply 5.19 squared plus 2 pi multiply 5.419 multiply 10.839. So the final answer is got is we got um, 552.565. That's all for me. Thank you.
In conclusion, this problem can be solved with these methods, which are by finding the radius and height of the can using the differentiation method, which are ds per dr. And second of all, by using the equation surface of area and volume of the tin can, which are S equals to 2 pi r h plus 2 pi r over 2, and V equals to pi r over 2h. After all, the cost of metal will be deducted since the dimension will also decrease. That's all for me and this team. Thank you.